In the first problem, we're given a probability p when x equals k, and then we have this bk p to the power of k minus 1. K is integers, so we know the variable x is a discrete variable, and then p is from 0 to 1. First question, we're asked to find b so that p represents a probability mass function. And so we know that a probability, if it is a probability mass function, then the integral of it should be 1. So when k is infinity, the integral of p should be 1. So here we can just do a little calculation here and have a summation. And we can notice this is kind of like a geometric series, but it is not. So we can see here eventually the summation equals b, and then 1 plus 2p plus 3p squared plus 4p cubed, and so on and so forth. And pretty much we can break this into the two geometric series timing each other. So pretty much this is 1 plus p squared plus p3 p cubed, and then squared. And then inside here, we have this really basic and simple geometric series with every term is just another p, right? And then we can use the summation formula, and then we get 1 over 1 minus p. And so b times 1 over 1 minus p squared equals 1, and then we can have b equals 1 minus p squared. Problem number 2, we're asked to find the expectation of x. So pretty much it's kind of like a continuous situation, but instead here we will just sum all the respective p when variable x equals k, and k is positive integers. And so yeah, we'll just time another k. So like inside the summation part, it becomes 1 minus p squared, and then k squared p to the power of k minus 1. And then inside here is also kind of like a different geometric series with different coefficients. So 1, 4, 9, 16, and so on. And then what we can do here is to time p on both sides. We can denote this 1 plus 4p plus 9p squared as s, and then we'll just time p on both sides and then do a subtraction. So s minus ps will become 1 plus 3p plus 5p squared plus 7p cubed, and then that will turn into a subtraction of two different geometric series as shown here. And so we can get s, right? And then we can use p to represent s, and that gives us 1 plus p over 1 minus p cubed. So going back to the expectation of x, we'll still have to multiply 1 minus p squared. So eventually here we get 1 plus p over 1 minus p. Okay, so the third problem is really similar. So inside here we have 1 plus 8p plus 27p squared. So basically this is just cube numbers. Yeah, and we can just use the same strategy as described above. We'll just let s be 1 plus 8p plus 27p squared, and so on and so forth, times p on both sides, do a subtraction, and then we have 1, 7, 19, 37 as the coefficients. And then we'll just do it another time, and this time it will finally we will finally be able to see some pattern. And here we just have pretty much everything is multiple of 6, so we can just take the 6 out, and what's left is the kind of like a geometric series with different coefficients, and inside the brackets here, p plus 2p squared plus 3p cubed is basically what we just got from the first question. And so we can use the conclusion here directly. Oops, sorry. Yeah, and then eventually we'll just get s equals p squared plus 4p plus 1 over 1 minus p together to the power of 4. And then by multiplying the b, which is 1 minus p squared, we get this p squared plus 4p plus 1 over 1 minus p squared. Okay, so problem D would be kind of easy. We just need to do a subtraction and then some pretty easy fractional work. And then we'll get this 2p over 1 minus p squared. And the last problem, when p is equal to 1/3, find the conditional probability mass function. Given that x is between 2 and 5 inclusive, and the probability of x when x equals k. And so we can see here pretty much a conditional probability can be written as the joint probability over the big probability, big conditional, the outer part. So yeah, we can see here basically this is this probability equals the probability when x equals k and x is between 2 and 5 inclusive, and that those two things happen at the same time over the probability when x equals k and k can be 2 to 5, right? And so we'll just sum it all up when x is equal to 2 is equal from 2 to 5, and then we just sum it up using the probability formula that's given here, and then we can finally have the results. When k is equal to 2, 3, 4, 5, we have a value, and otherwise we have 0.